For those who don't know, and I know you know, I've been involved in FACE for representing the Army aviation for a number of years. FACE is an open standard trying to define both a technical architecture and a foundation for common operating system environments. And mostly the operating environment for the operating system is going to look very familiar. And RTEMS, well, there's forward already. So there's a space bar that works too, right? The first thing to know about is that FACE came about as an open standard consortium operated under the Open Group. It was started by Navy, NavAir, and Army Aviation about 6 years ago. And it operates, I guess you guys should know about, the NASA guys should know about OMB Circular A119. There are rules for how government organizations can participate in open standards. And this organization was developed specifically to allow government participation with industry. There's about 90 members depending on which month it is. So this is a very open market, competitive. It's supposed to be I can't say it. You can say that word? Cooperation? That's it. That's the word I can't get out. So there's supposed to be reusable software components that have defined interoperability boundaries, and there's the link. The key to the architecture is, if you looked at it from your standpoint and just threw CFS at this, the focus is on the CFS apps, which are the portable apps. They don't depend on hardware or anything. The transport service segment is comparable to the data bus in CFS, and you can correct me if I use any wrong CFS terms. The platform-specific segment is generally devices that change, but you always get the same device, like, say, a GPS. But the GPS may not hook up the same way, so you hook it up through an I/O service. And basically, the portable things you should be able to move from mission to mission. The other things, if you use the hardware, they come along, and then you reuse the data bus, right? The part I'm focused on is the part wrapped around the edge, which is the operating system segment. The operating system segment, when you get down to it, looks extremely familiar. There are 4 profiles, and the key is, if you notice that the fourth column is ARINC 653. So 3 of the profiles actually require ARINC 653. All 4 have different size POSIX profiles. So the security is very small. Security and safety base are small POSIX subsets. The first day I started on FACE, RTEMS naturally came within like 6 methods of having everything that was in the FACE profile. We actually have almost everything that's in safety extended, and we actually have most of what's in general purpose. The key that happened, though, anybody who knows RTEMS knows we don't have ARINC, and it turns out that DDCI Deos had a level A certified ARINC kernel with other capabilities that actually had no POSIX. So we had a chocolate and peanut butter moment and realized it looked like the right solution was to take 2 mature, robust operating systems, paravirtualized RTEMS, and then run RTEMS for the POSIX solution inside their unmodified kernel. The key is, though, when I talk about this, there's 3 ways to view this. One is to say we're strictly focusing on FACE Conformance, because we do plan to run it through FACE Conformance. But you guys don't care about FACE Conformance. That's just the reason we did this. The second reason is to focus on the path where you can start with a base RTEMS on a $5 board, run the same code on the POSIX services, and then move it into a protected and time and space partitioned environment, which actually is a meaningful thing to give you a real good path. It's exactly the same RTEMS that's moving along. Code is, for the APIs and services, is moving back and forth. So I wanted to do a little bit just to talk about what FACE. So there's 4 profiles, and they all look familiar. If you start with Safety Base as the middle, anybody ever worked on a system that only allocates objects, never allowed to free, and never exits? That's basically Safety Base type of system. The POSIX services are really cut down. Interesting, like general purpose, after general purpose, you don't have standard in and out and error not allowed. And when you get to security, it's focused more on gateways. Each of these profiles is supposed to reflect operating systems and application uses of the services that have actually been through various types of like safety certification, like FAA certification, and various evaluations. So the Deos 653 runtime actually satisfies the ARINC requirements for FACE. So they've got the required Part 1 services, and they have the required services from ARINC 653 Part 2, which are required under the FACE standard. One of the interesting things FACE does is it defines a subset of ARINC services which are supposed to be available to a POSIX application, which is sampling and queuing ports and the health calls in the safety and security profiles. So it defines a fairly normalized environment. Well, it isn't normalized, it's well defined. And it also, there's a test suite that comes with, goes along with the standard, which allows you to test application code to ensure that it only follows the allowed APIs, and it ensures that the OS actually provides those APIs. So when we did the initial audit about a year ago, we realized we had 8 methods missing against the safety base. And the cool thing is, if you've, without knowing what's been happening, if you've been watching the RTEMS mailing list, these services have slowly been added. And if hopefully this week, the mmap and shared memory code will go into the Git master. So we've added all of these APIs. POSIX dev control, the header file was added last week or week before last. And so far, so by the end of the year or first week of January, we expect to have all the services actually available in the open version of RTEMS. And then it'll be a matter of just adapting the mmap to work in the virtualized environment. The interesting thing though is when even though we're focused on safety base, if we look at the other profiles, at the moment, if you took RTEMS Git last week, you would have been missing POSIX dev control, which is actually not in the main POSIX standard. It's in an addendum with only one method. And the shared memory call is missing. And that should go in this week. Did the slide change? Yes, the slide changed. So you go to safety base. Interestingly, we're missing the same 2 calls because the security is a proper subset of safety base. Safety extended, the main thing we're missing is that this is a multi-process standard, not a single process. So we pretty much meet it, but don't have the multiple processes. So I mean, when you guys talk about using POSIX, you've got some subset which truthfully probably matches somewhere along in here without really formally verifying it. The general purpose profile, one of the things that's really interesting I find about the general purpose is that, for those of you who don't know, we use the same C library as SIGWIN. Well, all the methods in italics there are actually are things that should be in the math or C library but are not. But I looked at the math I've been tracking for a few years. They're also not in NetBSD. So there must really not be much code out there that uses them. Those are like, some of those I think are long double complex math, which I don't think is used a lot. So anyway, we have 90% of what's in, no, I'm sorry, we have, with the new network stack, we have 90% of what's in this. These profiles all have networking, which is different than the old POSIX profiles, the PSE 51 to 53, 54. So these were all designed for basically cockpit avionics, but generally this looks like a normal standard. It's a POSIX profile on top of ARINC, and then the services on top of it look like CFS if we relabeled CFS. It's all message passing. So basically, when we started talking about this, RTEMS had POSIX, they had no ARINC, and they had the ARINC and no POSIX, but we both had a long history. They have 18 years of certification. Deos came out of Honeywell, and then a number of years ago was spun off to DDCI. The original Honeywell team has followed it, and I can't believe it, but we've been around 27 years now, and the space history is long enough where I think at least one satellite I know of has reached end of life, and one has been deorbited, which was a milestone I don't know that I ever saw coming. Sometimes you look for milestones, and then sometimes they hit you. The deorbit was a long, you realize the mission has gone long enough to hit end of life, you've done something. This is another standard FACE picture. The idea here showing that the OS segment in FACE is composed of multiple classes of services. FACE even defines programming language subsets that are considered safe for embedded avionics use. So two of the components in there are their ARINC libraries for the ARINC services and RTEMS for the POSIX. We focused on the RTEMS POSIX, but all of RTEMS is really in there. We're only doing the FACE test, seeing what meets the FACE requirements. The classic API is in there. The dynamic library, libdl, is still in there. Every service is still in there. We just haven't mapped all of the device drivers down. We'll do that as people need them. So this is a high-level architecture picture of Deos. Basically, the idea here is in the upper rows, you just see that you generally will put your application in one or more partitions, and you can use, they encourage you to do user mode device drivers, and then those can map to specific hardware, so you have very good control over that. Deos, interestingly, is built on a model of dynamic libraries, so there's binary reuse from system to system. The intention is that the RTEMS image will also be a compiled binary that can be used unmodified from system to system. This is a standard RTEMS figure, and basically the hardware is being replaced with a paravirtualization layer in this solution. The board support package is an adapter to Deos, and the plan is we're not building in our TCP/IP stack. We're going to use theirs, which they have done certification work on, and the rest of the things just come along. And we've actually discussed using the RTEMS POSIX partition to run GNU ADA. So that it brings in a lot. So the overall solution looks like you're just running RTEMS in a partition, regular 653 code in another partition. They can communicate using shared memory or message sampling your queuing ports, and the Deos kernel just swaps between them. So far on the integration challenges, RTEMS had already supported paravirtualization on some architectures. So what we had to do was basically just ensure that it was properly adapted to the Deos kernel. So in fact, the Deos kernel has not been modified in this. So since we didn't really change any code in RTEMS except the to change the protected mode supervisor instructions with the proper user instructions in this environment, everything else compiles exactly the same. Mostly we've been working on the adapter and adding missing POSIX services so we can go through the FACE verification effort. So the cool thing is we both use GNU tools. One of the challenges was that we actually, RTEMS used a newer version of the GNU tools than Deos did, and we had a newer version of Dwarf than they were used to using. But they updated, so we're all on very recent tools. They also use Eclipse, and they've got a number of plugins that are tailored toward their environment integrated into it. And there's an RTEMS application builder that slowly is getting better as people make suggestions. But basically, you're going to start with a main in a POSIX environment as the default one. So far, there have been absolutely zero changes to Deos, and all changes to RTEMS that affect anything common have been to add more services and to improve the paravirtualization adapter layer. And all of that actually is in the Git master. So this will all be in line with 4.12, which should release soon. So this is a pretty clean solution. So basically, interrupt, enable, disable is replaced with calls in the paravirtualized BSP. We did find that actually the C library, for some reason, had some protected mode instructions in set jump, which I can't figure out why. They actually had been there so long that they predated the version control system, and no one had any recollection of why they were there. I have a vague recollection that I might have added them like in 92 or 93, but I can't prove that, and we know they're not necessary, so we just removed them. RTEMS has paravirtualized support for x86, PowerPC, and Spark. Deos actually supports x86, PowerPC, ARM, and MIPS. So the ARM is the only one that will be next. The Deos, so basically when you intersect us, the x86 and the PowerPC are there now. The ARM is the next one online. And the Spark I think requires work on the Deos side. Our RTEMS Spark port already runs paravirtualized in a number of environments. So one of the things that we've had to discuss, and it's kind of interesting in the OS group, I don't know that we've actually walked through as much as we should, because you're on the OS group too, what it means to get POSIX behavior inside an ARINC partition and maintain both schedulers so they look right. POSIX expects different things than ARINC. So we think we've made decisions that keep the behavior the same as much as possible, because POSIX is very event-driven and allows you to have a very flexible, and ARINC is a very rigid, manually laid out schedule. So there'll be, probably before this is done, there'll be two options. Right now, you just run to consume your entire time window, and time advances at the beginning of each one of your time windows to make up. So you might not have ran for a second, but so all of your delays and time has to update to make sure you actually reflect what went on in the outside world. Because normally you would be completely virtualized away from time changing. So basically you're responsible for knowing to make sure the delays that would have passed while you were not the executing partition are honored. So this will be an issue. This is a challenge, but I think the solution's right. There are only two solutions, so we'll probably end up giving both as an integration option. So basically you just schedule your POSIX windows in with your ARINC windows. Deos has a number of scheduling options. They have a rate monotonic option. They have a Slack scheduler. They have a multi-core solution. So you can schedule your POSIX in parallel. You can because they're virtualized, you can mix criticality of applications if that works in your environment. So it's essentially a very flexible environment. Notice you can schedule your TCP/IP stack to run, and I've tried to go through this fast because it's got a lot of pieces and parts, and there should be questions. So basically, they've got certified ARINC 653 with level A artifacts, and we've got a long history from the space and other communities. But putting them together lets you get the best of both worlds. So we are planning to submit to verification to get the certification, OS certification conformance, and I'm sure, like everything else in software, it's never really done right. We always keep working on it because we can always think of a better way to do it. And users tell you things that you could have thought of, you should have thought of, but you never remember, right? The real world is different than what you think it is. So that's why RTEMS has so many options, is because you guys have told us how to make it better and tweak things. I think Alan has been responsible for a few personally over the years. So any questions? I'm holding everybody up for lunch. Is that the problem?
Thank you, Joel.